Oh. So paalala lang po ni Ma'am Ivy na for the exam, handwritten dapat yung academic integrity. Trying to share my thing. Share screen. Okay. So dito tayo sa last specialization ng instrumental analysis natin. Okay. So we're going to go with the electroanalytical. So I'm not sure if you are familiar with this technique, but I think among the three technique here, this is the one that has a lot of money. Okay, ito yung talagang, we could say, booming, especially if you correlate it with the healthcare industry. Okay, so for instance, one of the product of electroanalytical methods ay yung tinatawag nating sugar meter or glucose meter. So why is it what we call the billion-dollar industry? Here in the US, 1 out of 10 Americans are diabetic, and that includes me. Okay, so from time to time, you have to monitor your sugar level. Okay, and they were able to come up with this device known as a glucose meter to be able to monitor. And I think mas high-tech na nga ngayon because they have already one that is connected to a cell phone, and all you need to do is sometimes you just have some patch, okay, and then some wirings there, and then you can just stop and they can monitor your sugar level from time to time. So what we're going to do today is discuss some of the electroanalytical methods and the experience that I have here. And most of this experience, believe it or not, was done, I think 100% was done there in the Philippines. Okay, when I was still there, way back 2003 to 2005 before I left for my PhD. Okay, so when we're talking about the electroanalytical methods, so this is an electroanalytical chemistry encompasses a group of quantitative analytical methods that are based upon electrical properties of a solution of the analyte when it is made part of an electrochemical cell. Okay, now the main thing that you have in electroanalytical method is this one, electrochemical cell. So if you're going to use look at the electrochemistry, what's the main principle behind it? Anyone? Ano yung main principle ng electrochem na tinatackle nyo as early as general chemistry? So usually just look at what? What type of reaction?
Sa redox po.
Okay? It's the reduction oxidation reaction. Yun yung pinaka basic principle behind ng electroanalytical method. Okay? And they monitor it usually using the so-called electrochemical cell. So the main advantages of this method is it's open specific for a particular oxidation state of an element. Okay, so which we could say element usually oxidized? Usually the what? Anong element yung expected mo mag-oxidize? Because we have an environment that has oxygen. So whatever happened, this type of element will always oxidize. And these are what? Yung mga metals, right? So metals, we could say, it will always undergo oxidation. And they said if you can find a process that slow down or prevent oxidation, you can make big, or you can be rich if you're going to find or develop a method for this. Because whatever happened, okay, metal will undergo oxidation. Specifically, the term that they use there is corrosion. Okay, and the classic example that I always give my student here is the Statue of Liberty, because they said it's made of copper, but if you're going to look at the Statue of Liberty, it is green colored. So what happened to the copper that is usually brown? Okay, may brown pa naman if you go inside the statue. Okay, so hindi kasi siya asing exposed kaysa doon sa labas. Now, I think the main advantages of the main advantage of an electroanalytical method is it's cheap. Okay, it's low cost. Its instrumentation is relatively inexpensive. In fact, I think I'm 100% sure all of you has experience using an electroanalytical method device. Okay, maybe you don't know it, but I don't know if you're familiar with the pH meter. Lahat ba nakagamit na nito? Because usually, if you have a basic laboratory, if you are asked what you need to do, I mean, the 5 basic instrument that you need. So number 1 dyan ay yung balance. And then number 2 is spectronic 20. And then number 3 would be the pH meter. Ang last na ano nga dyan ay yung mga chromatographic system, because they are more expensive compared, let's say, with the absorbance or electroanalytical method. Okay, in blood, this what we call glucose meter. What makes it expensive? If you have relatives who have the glucose meter, ano yung nagpapamahal doon? Hindi yung device, di ba? What makes that what we call the device more expensive is usually the strip. Okay, because the device that you have, it can last forever, but all you need to do is you have to buy the strip where you drop the blood. Okay, yun yung nagpapamahal. Okay, but if you're going to compare it, let's say, with the other instrument that we have discussed, the instrumentation for electroanalytical methods is relatively inexpensive. And the thing that you look at this one, it doesn't measure really the concentration. What it measures are the activities. Okay, it provides information about the activities rather than the concentration of the chemical species. Now, usually, what's the relationship of activities with concentration? Usually, activities is just what? Concentration times a certain number. Activities are usually what? Lower than the concentration. If ever they're the same, okay, but they're usually happen rare. If you're going to look at what they really measure, it's really the activities of the target analyte that you have, not the concentration. Okay. Now, if you're going to look at the electroanalytical methods, marami sila. Okay. And I tabulated them here. So I summarize all of them here. Okay. So if you're going to look at these electrochemical methods, it involves the analysis of chemical species throughout the use of electrochemical methods. And if you're going to look at this, usually if you have these interfacial techniques, the way that you look at this is the potential, the charge, or the current depends on the species present at the interface between an electrode and the solution in which it sits. So usually, whenever you have an electrochemical methods, you have an electrochemical cell and you have electrodes. And what you do is you look at, okay, the interface between the electrode and the solution that it is. So it can be potential, charge, or current. So potential, usually what you have there, a voltmeter, okay, or voltage charge would be what? Coulomb. So you have a coulometer. And then current would be an ampere. So you have like an amperometer. Okay, so there's usually the name after them. And if you're going to look at these interfacial techniques, it can be static or dynamic. Okay, so when you're talking about static, the current is not passed through the analyzed solution. So what you have here is you measure the potential directly. That's why in the static methods, you have only potentiometry. Okay. And what's the classic example if you have a potentiometric technique? Anyone? And as I've told you, you have already experienced here. Okay. The most experience that you have, I think, is potentiometry. That's where you measure
pH, sir.
okay, the pH or ano pa? I'm not sure if you're familiar with this term. ISE. Are you familiar with ISE? Anyone? ISE stands for ion selective electrode. And that's the experiment that we do in this part. So each element, they have their own electrode, ion selective electrode, and you use it. Now, the principle that you have here is similar to the pH. So we could say pH is just the ISE for hydrogen ion. Okay? Yun yung ano, yun yung pagkakaiba ng iba. But if you're going to look at the setup, it's always the same. Okay? So in the potentiometry, you measure the potential. Okay? Now in the dynamic techniques, what you do here is you allow the current to flow through the analyzed solution. And it can be either coulometry, amperometry, or voltammetry. Okay, that's the main, we could say, specialty dito sa dynamic techniques. But if you're going to look at this, meron pa silang subdivision. For instance, if you have a controlled current, okay, you measure the current versus time, you call it controlled current coulometry. If you have a controlled potential, well, it can be a fixed potential or a variable potential. So if you have some fixed potential there, you're measuring the current at fixed potential, that is amperometry. Okay, that's the measurement of the current. But if you control the potential, okay, but when you measure the current versus time, what you have there is the controlled potential coulometry. So when you have this coulometry, it's a current as a function of time. Compared to amperometry, it's just a measure of current as a function of fixed potential. Now, kapag yung potential mo ay variable, you have their voltammetry. Okay, so those are the different electrochemical technique or electroanalytical techniques that you have. Okay. Now, doon sa variable potential, you can have a stirred solution or a quiescent solution. Okay. And both of them measure current versus potential. Now, if it's a stirred solution, you have their hydrodynamic voltammetry, which measure the current versus the potential. But if you have this quiescent solution, both of these is what we call stirred solution and quiescent solution, you have stripping voltammetry. But if you're going to look at them specifically here, okay, you can have one that is a linear potential giving you polarography and stationary electrode voltammetry. If it's involves pulse potential, that's pulse polarography and voltammetry. And if it's a cyclic potential, that's called cyclic voltammetry. Yung tinatawag nating CB. Okay, and usually CB is the one that is used if you want to determine the redox potential of a given system. Okay, because what it's going to do, it's just going to run deeper at a potential range and determine what's the current of your given system. Now, what do you think is the one that involves the glucose meter? Which method it is? Anyone? Alin dito sa method na to yung involve yung glucose meter? Have you heard what method is that? Now, to answer that question, okay, the one that the principle behind the glucose meter is this one, amperometry. So the way that they look at it, they find the potential where they can convert the sugar, okay, the glucose to I'm not sure if it's glucuronic acid, okay, and they measured the current at that certain potential, and they found out, okay, the more sugar that you have, the higher is the current, and that's the principle behind this, what we call glucose meter. Okay, so yan yung tinatawag natin billion-dollar industry. So if you're going to be able to find a cure for diabetes, you're going to be what we call rich, but you have to make sure you have all security, because you're going to kill an industry, a profitable industry overnight. Okay, now let's look at the instrumentation. Okay, so in voltammetry, as we mentioned here earlier, it measures a current as a function of a variable potential. This is a type of electrochemical method which is used to measure the produced current by the application of a specific voltage on a working electrode. So what we said, we have an electrochemical cell. Now usually they are made up of what? 3 electrodes. And what are these 3 electrodes? Meron tayong working electrode, reference electrode, and counter electrode. Okay, so the working electrode is the microelectrode whose potential will vary with time. Now the reference electron, what we'll do, it potential will remain constant, and you can have a silver chloride electrode as reference electrode, or a saturated calomel electrode. Now the counter electrode usually is platinum. Okay, before they use this, what we call mercury, but they phase out mercury because of its safety issue. Okay, when we say mercury here, this is the liquid mercury. So the counter electrode, okay, or in other books they call it the auxiliary electrode. They complete the circuit. So what the auxiliary electrode do is conducts electron from the signal source through the solution to the working electrode. So this is how it looks like. Okay, the 3 cells, so all of them in an electrochemical cell. So you're going to apply a potential to it, and the current will be measured, okay, and then transferred to what we call a readout system. Now, one technique that they develop of this voltammetry is known as polarography. Okay, it was developed in 1920, and Yaroslav Hebrovsky got the Nobel Prize in 1959 for this technique of polarography. So when we're talking about polarography, this is a particular type of voltammetry which differs from other types of voltammetry because the working electrode is unique. That's your dropping electrode. Okay? Ang ibang name niya dito is HDME, hanging dropping mercury electrode. Okay? Unfortunately, because of the use of mercury, okay, it pays out. But even though the use of polarography declined, the method of voltammetry have grown at a much astonishing pace using the same working electrode. Okay. Now, the voltammetry that we have, it measures the current that flows as the applied potential is what we call varied. So from this current measurement, information of the analyte is obtained. And the analytical voltammetry comes here in the form of the so-called voltammogram. So that's the current produced by the analyte versus potential of working electrodes. So when I was there in the Philippines, I took over the instrument, the voltammetric analyzer 693 by Metrohm of Dr. Jose Santos. Okay. And I just continued what he was doing during that time, which is just developing working electrodes for metal detection. Okay. So the way that we look at here, we try to develop these working electrodes using carbon paste and put with the so-called modifier, which I'm going to explain to you as we go on. Okay. Now, one technique that we have here in voltammetry is yung tinatawag na CB, cyclic voltammetry. So this is an electrochemical technique for measuring the current response of a redox active solution to a linearly cycled potential sweep between two or more set values. Okay. CB is more like scanning for the reduction potential at CB is just scanning the reduction potential at a particular range of potential. Okay, it is useful because it quickly determines information about the thermodynamics of the redox processes, the energy levels of the analytes, and the kinetics of electronic transfer reactions. Okay. You can also use this method to look at the mechanisms of the redox reaction in a given solution. So whenever we develop the working electrode, CB is one of the items that we look because we want to look at the reduction potential. So the way that it looks at here, okay, so pwedeng magsimula ka in the negative region and then you ramp the potential going to the positive, okay? And then once you reach the positive region, you ramp it again towards your starting point. So what we do while we're ramping it at the opposite direction is you're doing reduction and oxidation at the same time. And if you could see an electroactive species, you're going to have a shape like this, like a duck. Okay. And this is for information is useful. It gives you an idea what are the electroactive species that you have there in a given system. Okay. Now, some of them is just like, I don't know if you could see an image, a mirror image thing here. Because in some instances, you just see it like that and you don't see this anymore. So yung ibang ano, diretso lang yan ganun. Sometimes it's just like this. So anything that you see a peak there, dapat may mirror image no kabila. But sometimes you just see it like that. So it can tells you a lot of information if you are in electrochemistry. There's a lot of interpretation that goes along with it. Okay. And then if you want to determine the amount, so this is where you try to develop a quantitative method. Okay. So either you use this differential false anodic stripping voltammetry. In some book, you can have the adsorptive pamalit doon. And in some, they have the LSB. L is just the linear. So this is a technique where the analyte of Vista is first electroplated in the working electrode before being removed or stripped. So dito na yung ini-strip. Okay? So how do you strip it? You apply an oxidizing potential. Okay? And the way that it did here, since you're applying this potential, so you're converting your target analyte, okay, to its reduced or oxidized form. Now, during the removal, the cell current is measured as a function of time and as a function of a potential between the indicator and the reference electrode. And the current is usually sampled before and after voltage pulse. Kaya meron tayong tinatawag na pulse, differential pulse. So nag-a-apply ka ng voltage pulse doon. Okay? So the way that you're going to have it here, so these are the three electrode system. So the first step that you have would be accumulation. So the working electrode that my students developed before they're in UPLB, they put modifier here. So the characteristic of the modifier is it can bind with heavy metal. Okay. And then we put it with carbon paste, which is with carbon paste and Nugent oil. And then we just use the copper wire that we have there. And then it was used as the working electrode. So once we do the accumulation, what we do next is the deposition. Okay. And then after the deposition, we do the stripping. So the deposition, we converted, okay, whatever that binds there, okay, and we get the reading out of it. And then when we do the stripping, okay, we converted it again, okay, to at least get the signal that corresponds to the amount of the metal that was there in the modifier. Okay, and I don't know if you went to UP, the IC, does this still exist, Emil? Meron yung tinatawag, ewan ko kung air room pa rin yun ngayon.
Sir, parang hindi na po.
Wala na? Okay, this is how the instrument looks like during that time. So this is the Metrohm, and this is the electrochemical cell. When we blow up, this is how it looks like. So as you could see there, I don't know if you see, that's a copper wire. Okay, so inaano lang namin to doon sa pipette tips. Okay, tapos meron kaming isang electrode dito, tapos isang electrode dito, and then we have like nitrogen to remove any of the oxygen that is present there. So this is the system that we have there. And we were able to make a lot. I mean, a lot of students, I think I have 18 to 20 students who did their thesis for 2 years here. Okay, and some of the papers that come out is what we were able to publish. So I'm not sure if you're familiar what is this. Are you familiar what species is this?
Cockroach.
It's a cockroach. Okay. So what one of my students do is, you know, yung ano ng cockroach, balat niya. Okay. So there's what we call report that it would bind with metal, so we use it as a modifier. And then another students that I have, ang ginamit naman niya is yung pineapple. So what do you have in pineapple? Why do you think we use this one? Anong meron sa pineapple? Yung ano lang to, yung mga waste material ng pineapple. Okay? I'm not sure if you're familiar with. Are you familiar with this? Bromelain. It's a protease, I think, enzyme that is present in pineapple. Okay. I don't know if you know the chemistry why you use pineapple doon sa karne. Ano ba luto yun? Meron tayong ano, di ba, yung menu na niluluto natin yung karne natin with pineapple. But do you know that there's a chemistry behind why you use pineapple? Okay, mixed with meat. The same thing, the same principle that you have with papaya para doon sa tinola. You use them because they have these proteolytic enzymes that will break down or make the meat more tender. Okay, so that's the idea that we come during that time. And then another student, napansin niya kapag nag-organic chemistry, doon sa essential oil. So nangongolekta kami noon. So let's say, let's try. Okay, let's see if it's worked. So they were able to what we could find out that it's worked, because the idea that we have there in the modifiers, if you have a functional group that binds with metal, most likely it's a very good modifier. And what I ask my students is just to use waste material, okay, that can bind heavy metals. That's why one of them used this what we call papaya. Oh, no, banana. Because banana has what usually happen if you expose banana for a while, di ba nagba-brown siya? So that means it has some enzymes that contains there. Okay, so we're taking advantage of the binding of protein-based material with the metal. So that's just some. Okay, so there are also one, I don't know if you what we called heard it, but we have feather. So the way that we name this is just end them with trode at the end. So there's feather-trode, piña-trode, banana-trode, okay, apple-trode, okay. So the way that we do is the modifier that we have is just material containing metal binding functional group, okay. And the feather-trode that I have, so when they do the CV, so you could see the difference. One that just contained the carbon base electrode. So when we say carbon base, ito yung graphite na makikita natin sa lapis, but in the powder form. So we mix it, okay, with nodule oil and the modifier. So as you could see, there's really a difference between the redox potential of that just contains the CPE, the carbon base, and the one that contains the feather. So the difference of this with this one is something to do with the presence of the feather. Ano kaya yung functional group na meron tayo sa feather na maaring mag-bind sa metal? Anyone? What does feather has? I think it's associated with the protein that is in the hair. Okay, so the presence of this what we call keratin. So we take advantage of that. So keratin contain usually what? What specific element? Yung nagpapabaho kapag nasunugan ka ng buhok. I don't know if you experienced that.
Sulfur po.
Okay, it contains sulfur, and sulfur usually is a good binder for heavy metals. Okay, so yung sulfur yung nabaho. Last time na nangyari yung birthday ng anak ko kasi pag blow niya ng candle, ano yung buhok niya. But I think there in our country, pag meron kang brown out nung bata ako, mga ngamoy lang, oh, ba't amoy, ang baho nung amoy? Yung nasusunog na pala yung kilay mo dahil dun sa gasera na ginagamit mo. Okay? May brownout pa kaya ngayon dyan, di ba? And then we use also this DPASB. So as I've told you, this is a quantitative method. So meron kang current na ma-measure dito. So here, we're just comparing the one that just contains carbon plates and the one that contains the feather. And as you could see, kapag nilagyan namin, we both put it in, if I'm not mistaken, we have lead 2+ there. So the unmodified doesn't have any lead. So that current is due to the lead metal. And the more lead that you have, okay, the higher is the current. So dyan nagagawa yung quantitative analysis. Okay. And then my students optimize the condition, yung percent modifier. So as you could see here, as the modifier increases, the amount of modifier increases, the signal that you get decreases. Okay. Now the main reason to this is yung saturation point. So we just want to determine at what maximum at what concentration we can get the maximum signal. So it's just 10%. Okay. And then accumulation time. So usually the longer the time, the longer the accumulation time, the more metal that will accumulate. But we could see meron siya ring tinatawag na max. After that, hindi na siya makaka-accumulate, or we could say all the binding sites has already been used. And then we also determine the pH, okay, from pH 2 to pH 7. And then we also determine the deposition time. Ito yung pag-convert, okay, doon sa na-accumulate na Pb2 plus, we convert it to Pb0, okay. And then this is how the signal looks like. We also use a different potential doon sa deposition niya, okay. And then we do this stripping analysis. So usually it's the first stripping that what we call the highest, because that's when almost all that was in your electrodes are removed. And once it's removed, usually only small amount is present. And it's a very good regenerating or regeneration process if you want to reuse your electrode, okay? And to determine if it's a very good analytical technique, we compare the same samples using DPSAP and atomic absorption spectroscopy. And we found out it's close to one another, although the AAS is what more accurate, okay, or we could say more precise. They're close to one another compared to the DPASB. Okay, now we also look at the figure of merits, so other figures of merits of the Feather-trode. So when we use it for 5 milligram per liter a lead solution, the mean is around 4.52 microampere, okay, with the range from 4.39 to 4.67, giving us a relative standard deviation of 2.43. Now for 10 milligrams per liter of lead solution, so it's 8.64 mean with range of 8.19 to 8.97. As you can see, it's a little bit linear. Dumoble yung signal niya after doblehin namin yung concentration. And the RSD is unfortunately higher. Okay, so we determined the limit of detection, and we found it as around 0.59 milligram per liter. Okay, and we use the DPSAB method to measure some samples. Okay, yung tinatawag naming waste sample that we suspect contains lead. And this is how they are what we call different from one another, but at least they're close. Okay, and we are able to make a lot of what we call papers out of this, most of the time when I was already out of the country. Okay, because I left 2005, but 2007 I was still able to what we could write some of the thesis done by my students, and some of them are still what we call not done. And also the experience that I have in electrochemistry was boosted when I went to Austria for 1 month, okay, to work on carbon-based electrodes. So I was able to make a paper out of it here. But this time we use it for the glucose. Okay, so I just spent there 1 month, all expense paid trip. Okay, but it's really hard because you have to speak German, and I don't know how to speak German. Okay, and the thing is, pumayat ako because they don't have rice, so all I eat the whole day there is kebab. Since malaki yung kebab for lunch, I also already eat it for my dinner. At pumunta ako doon, tuturo lang, yeah. the experience that I have there, and their bread is so hard, okay? And that's the first time I encountered, I'm not sure, are you familiar with Nutella? Yun yung first time ko na kumain ako ng Nutella. During the time, Nutella was not yet available in the Philippines. Okay. And we have a lot of papers from that, what we call the experience that I have in electrochemistry. Now, you might ask why when I came here to the US, hindi na ako nag-electrochem. When I arrived at the University at Buffalo, the one teaching electrochemistry is an 85 years old professor. And the first thing that he asked me is, do you know Victoria Beckett? And then I remember that's a professor in UP Diliman before. And Dr. Beckett was his student way back in 1976. So it's very what we call, I said, hindi yata kami magkakaintindihan nitong professor na to. And true to it, the one student that we had in our batch, I think graduated 2 years after I already graduated, I finished my PhD. Okay. And I think he retired 5 years after I left the grad school. Okay, all the department want him to retire because he's not doing any more productive research. Okay, to the point that they gave him undergraduate course. Okay, para at least ma-retired lang siya. So that's the reason why I stopped doing electrochemistry. But it's a very good, we could say, field. Okay, so during the time that I was there in UP Los Baños, so I would say Dr. Joey Santos was the one who mentored me to do that. And these are just some of my students who I still have in contact at this time. Unfortunately, iba nagkaaway ko na ngayon because of the politics there. Okay, and they're just part of, let's say, the time that I started my teaching career there in UP Los Baños. Okay, so most of them are already professionals at this time. Okay, and last 5 years, I'm trying to do electrochemistry again. I was able to, the department was able to give me money to buy a benchtop voltammetric analyzer. And then a collaborator that I have in UP Diliman was able to give me money so that we can have this portable voltammetric analyzer. So this is just a very small thing. I think ganito lang kalaki. Okay, and I'm planning to do it again because they gave me the money to analyze for the heavy metals in milk. We're not able to get it in the AAS because of the detection limit. Masyadong mababa yung level ng metals to be detected in AAS. So we still have money. So I asked him if I can use that money here. And also when I went there in UP Los Baños in 2018, I worked with Dr. Migo lab trying to determine the industrial waste. So she wants to have electrochemistry of industrial waste. So I was able to use the setup by Dr. Lilia Fernando. And that's the time I also met, I don't know if you know Franco, okay, who is also an IC faculty at this time. So that's the time I said I got interested back in electrochemistry. And what we're trying to do now, remember you have your sample in propolis. So we're trying to look at, can we differentiate the propolis based on the electrochemistry that it has, maybe just using the cyclic voltammogram, because what does this propolis has? The so-called antioxidant activity. So that means there's a reduction oxidation reaction that is happening in the given system, and there are some papers that report that. So we're trying to what we call use this one, and the good thing, the electrodes that they have right now, it's just like the strips that you have in your blood sugar. Okay. So you just put all the clips, I mean the 3 electrode system, all of them, if you're going to look at it, so meron siyang parang ganito, and then all of them is connected, tapos merong sample, a drop of sample is all you need. Okay, and then you put the alligator clip, that is the one that represent each of these things here, represent an electrode, and then you put your sample there, so connected yun doon, and you can now get the reading that you want. Okay, Now, for the experiment that we have, I'm just, I think, show you a video. We're going to analyze yung tinatawag nating fluoride. So I'm trying to what we could go get the video available. I'm trying to. Where is it? Oh, wala. Nasaan yung video na yun? The next thing that we're going to do here is to get. I think we will make this available to you. The reading of 0.1 ppm fluoride. So as you could see, it's not as high as the one that we have earlier. Okay. So 112.3. So there's a stable now. So now we have 1 ppm. So we will wait for the sample to stabilize. So as you can see there, it's showing already. Okay, so you have what, 85.8. So you can put it there, 85.5. So from the 85.5, okay, 1 ppm, we now have 50 ppm. So as you're going to look at here, the stable sign is already coming out, so it's 43.9. So from 43.9 reading of the 5 ppm, we now go to 10 ppm. So if you're going to look at here, I don't know. The stability is much faster because you have a much higher concentration. Nakikita niyo ba? Teka lang. Natanggal ko ata eh. I'll try to do it again. Nasaan na yun? I think this is a much better one. So the next thing that we're going to do here is to get the reading of 0.1 ppm fluoride. So as you could see, it's not as high as the one that we have earlier. Okay, so 112.3. So there's a stable now. So now we have 1 ppm. So we will wait for the sample to stabilize. So as you could see there, it's showing already. Okay, so you have what, 85.8. So you can put it there, 85.5. So from the 85.5, okay, 1 ppm, we now have 50 ppm. So as you're going to look at here, the stable sign is already coming out, so it's 43.9. So from 43.9 reading of the 5 ppm, we now go to 10 ppm. So if you're going to look at here, okay, the stability is much faster because you have a much higher concentration. So 25.5 is the reading for 10 ppm. From the highest concentration, we now go to different samples. So this sample is, if you're going to look at the tap water. So tap water we know has some fluoride, but it's not as high as the one that we have read. And as you're going to look at here, it takes a while before we can get a stable reading. But there it is, okay, stable reading.
Come on. So after
Nawala.
the thing, we have mouthwash. Now mouthwash here, this is just close to 10 ppm. See that? It must be even higher. So if you're going to look at this table that we have there, okay. And last but not the least, we have the toothpaste. So let's see how the reading of the toothpaste is. There, stable already. I want also you to look at the sodium monofluorophosphate. That's around 0.70 or 76% or 0.15% weight by volume of the fluoride ion. Okay?
So that's the one that we're able to get. We're supposed to do an experiment, but we have a problem with the fluoride electrodes that we used last weekend. So I'm not sure if we will try to do it again next weekend. Okay, but that's how you're going to have your report, at least for this electroanalytical part. Question? Tanong? Question? May tanaw? Class, may tanaw? May nagtanong. Not for. So ano? Nababayaran ko na yung ano, tapos mag-register na kayo, just email me para ma-send ko yung name doon sa KKP. Final output. Which final output? This one? If I'm not mistaken, this is a written report. Similar doon sa HPLC ninyo. Yung data treatment, if I'm not mistaken, yung offer sa inyo, if you opt to do the data treatment, you still like do some sort of a report doon if you pursue that venue compared doon sa research proposal. It's just you're writing also something. Sa research proposal is you just present the thing. Doon sa data treatment na ibibigay sa inyo, you still going to write something about doon sa ginawa ninyo. So you have to let us know as soon as possible so we can give you the data. Kung gusto nyo yung venue na yun instead of the research proposal. So any more question? So next week nyo i-report yung PCA. How's the MATLAB? Okay ba? Do you think it will be useful to you?
Okay naman, sir. Pero yung sa samples namin ay walang masyadong replicate. So yun lang po.
Okay lang, you just use what you have because the sample that were given to you, kasi yung sa pag-collect ng samples, yung machine, pwede kang mag-collect ng 5 replicates as it is, or 5 replicates save as the average of, the average of 5 replicates. Yun yung mistake namin noon. When we're doing that, we don't ano ba tawag doon? We don't have an idea that we're going to use a PCA on that. So nung nagko-collect kami doon, sabi namin para kasi may option na yung instrument na magkuha siya ng 3 runs tapos isang run lang yung lalabas. Kasi sabi ko, kukuha ka ng 3 runs tapos i-overage mo sa Excel. E di kumuha ka na lang ng yung overage run, overage ng 3 run. So ganun yung nangyari doon sa mga data na yun. But the data that we're doing now, because of this option that we're going to use this chemometrics method, yung talagang meron na kaming data for every run. So yun yung mga ibibigay sa inyo if you opt to do the thing na magda-data treatment kayo. The idea of me of venturing here in this so-called use of PCA just happened during the pandemic because I want my students, my research students, to do something, okay? And we have a lot of, we could say, data, so maybe we can use more on this data that we have. So aside from that, yung una nga namin ginawa is the so-called derivative spectroscopy. So the way that you do it is you have your raw data, which is the zero derivative, and since we want to differentiate them, okay, based on the different sample, so sabi namin, pag first derivative ba namin to, makikita namin yung difference. Pag second derivative ba namin to, makikita namin yung difference. And then the opportunities come when I met Dr. Pilario. Ayaw ko maniniwala kayo. I met him on Facebook because he was staying near some of my relatives in UK during his PhD. And I think one of my relatives said, oh, I also have a relative who is now in the US but used to teach in UP Los Baños. So if you want, you can do that thing. So yun yung parang nagka-idea ako, oh, mag-venture na lang ako. And to tell you frankly now, in addition to MATLAB, I'm not sure, are you familiar with R? Narinig niyo ba yung R? I'm trying to show it to you because this is one of the things that they usually use now, yung tinatawag na R. Oh, I don't have it here in my laptop. It's in my other laptop. Oh, I think I have here R. Teka lang, binubuksan ko yung R. It's similar to what we have with the MATLAB, but what's the difference with this R? Libre siya. Yung MATLAB, kailangan mo ng yung subscription, but this R is what we call free. So I'm not sure if I can show you. Pag nakita niyo yung yung style niya parang ganun din eh. So ito yung parang yung sa R. But I'm still what we call learning the system. But I have a grad student who is taking a course taught by a professor in mathematics. So I told her if she can do analysis of the R and we want to compare it with the MATLAB, then that would be a very good idea. Okay, so maybe the next what we call 230 instead of the MATLAB, or in addition to MATLAB, they can also use what we call this R. Familiar ba kayo dun sa R? When I'm talking about R, yung letter R, yung mismong letter R. Have you heard about that?
Hindi pa po, sir.
Ba? Because I don't know if you know it, but one big field that usually right now ay yung tinatawag na data science. Okay? So the way that they try to look at this data science thing is mas maganda daw ang training, okay, ng mga estudyante kapag meron silang some sort of computation or R. So if you I'm going to show you here the website for the R. I'm not sure if there is someone who have used it already there in IC, but I met who's that? Professor Tapia. Pero ang ginagamit ata nila Python ata. That's the one that they using. R is mostly used. I have a friend here in PACE. She's using it in biology kasi ano siya ecology specialty niya. Okay? And from time to time, I asked her, bakit hindi tinuturo doon sa level? Sabi niya, advanced na daw yung R. Yung gusto niya na gawin ko na PCA using the R. But he said, it is still possible to use that thing. Pero hindi daw tinuturo sa undergrad level kapag principal component analysis yung R. Okay? Because I remember Dr. Laksamana, the IC director, asked me, can you teach chemometrics? And I said, no, because I'm not really still confident on my knowledge on this chemometrics. But I'm trying to do it because I know they're useful, but unless I am really at depth on how to use it, then that's the only time I'm going to teach it. That's why at least this semester, you're lucky. We have the MATLAB and we're able to invite Dr. Pilario. And if you know how to use that, what we call MATLAB, you can include it in your CV, okay? That you know how to use MATLAB. Yun yung labanan dito ngayon eh. We heard some students that they got hired because they know how to use R. So the thing that I want, at least, even though we have this online mode of teaching, at least you're still equipped with some tools that are really being used in the scientific field. So yun lang yung parang gusto kong ma-share sa inyo. Okay? That this is the one that is common. Because I remember during my PhD, one of my professors said, you know, your paper will be strengthened if you don't only have experimental data, but you also have theoretical data. So I was forced to learn some computational method. I use Spartan, I use Gaussian, and what we do is in most of my papers, I usually compare yung experimental result with some theoretical results na kinalculate namin using these different computational package software. I'm lucky that we have that what we call software. I think I can maybe baka next semester those students who will take the course, if they already have access, I can ask them to install that Gaussian thing. I left it with some faculty there in UP Los Baños. And you can use it for let's say the HOMO-LUMO calculation. My main aspect of using it is in IR and Raman spectra and getting this spectra. So I compared it with the experimental results that I have. So question. Yung Gaussian? Anthony, ginamit mo yung Gaussian? Yung R. So at least you have already experience in using R. Libre siya, di ba? I did something because my colleague asked me, okay, try to do this. And then I asked him for a follow. I said, not now. I'm so busy this semester. Because I asked her to teach me. I think it's the R Studio, the one that you have. So I'm trying to show you that how the R looks like is really the same as the MATLAB. Ito, meron na ako nakuha ko na yung yung Gaussian software na ko, I think is the 09. I left it to some faculty there. So ito yung parang mga command na binigay. You see the R now? This is something in your screen. So ito yung parang pinagawa niya sa akin. So it's just like you're doing what we call your I think I have a files. I have a files. Wala ata. I'm trying to show you recent file. Okay, ito yata yung recent file. Oops. Wala. Hindi pinapakita yung yung mga jobs kasi usually kapag oh no. Okay, allow. Yeah. So parang mag-send ka doon tapos may lalabas na sagot. If I run it there. So 2 plus 2. Tapos ito pag ni-run mo, nakikita mo niyo yung nangyayari. Square root of 4 is equals to 2. Do you see? Nakikita niyo ba? So kapag nag-ano ko 4 raised to the 3, so lalabas doon 64. And I think, I'm not sure, parang mas nabilisan ako dito sa R kaysa doon sa MATLAB. Saan mo ginamit yung R, Anthony? Anthony, sabi mo may experience ka sa R. Saan mo ginamit?
Sir, para pong modeling po. Gumawa po ng statistical model.
Kasi may binigay siya sa akin. Oh, if you want to learn more, and the book is so thick, sabi ko wala akong time magbasa. But there are a lot of what we call YouTube videos that you can learn something, and sometimes I watch it. Okay. But the thing that I always told myself, meron naman akong, so yung isang grad student ko, I'm giving her until the end of the month. And I told her, okay, you run this data that I have, and at the same time, I run it in MATLAB. So makita namin yung difference. No, but the thing is, they should be the same. Kung ano yung result ng isa, dapat pareho din. Kasi you what we call use the same set of data. Okay. But I would suggest you try to do that because it's going to be helpful. I think for your own personal growth. Okay. So tanong. So yung naka-register na sina Amiel, si Jeb, si Karen at si Stephanie sa KKP. So I know maybe meron kayong tawag dito na other schedule or class during that time, but just attend it. Okay, ako lang bahala doon sa registration. I'm going to send the payment tomorrow. So kung meron pang extra, I will meet my Chem 137 class tomorrow. So I will what we call give them the opportunity also. Okay? Kasi libre yung first 100 eh. But I'm not sure kung available pa yung first 100 session.
Sir, bale po, 99 over 100 na po yung
talaga?
registered na undergrad students.
Talaga? Kasama ka sa
As
organizer?
of, ano po, under po ng secretariat
Okay.
committee.
So at least
So, bale po, isa na lang po yung slot for undergrad student po as of kahapon po.
talaga. So kung sabihan nyo agad ako, maybe by tomorrow morning, isa-send ko tomorrow daytime dito yung money. So when I meet them at the same 11:30 tomorrow night dyan or tomorrow morning dyan, I will just tell them, okay, kung ilan man yung slot na matitira doon sa perang sinet ko. Okay, the first 5 na gusto mag-intend. And I think some of them already registered also because they are also students, not only 137, but also like 140 and 111 and 112. Okay. So maybe give them an opportunity to attend an event like that. Okay. Grabe 99 over 100 agad.
Marami din po atang nag-invite na mga professor po from IC.
So the announcement came when wala na yung hindi kasi usually nagmi-meet lang kami every Tuesday, and then I recorded the session, and then last Thursday we're supposed to meet last Thursday, but Wednesday last week my hell we could say hell day. Ang dami naming ginawa nung Wednesday afternoon. So when I arrive home, I'm so tired. So I just texted them. I think I cannot meet you. So can you just watch the 2 recorded video? And also, the same channel where I posted our class and our video, nandoon din video nung 137. All you need to do is you scan all the videos on Just Channel. So tingnan nyo lang yung 137. Okay? So I think we have chromatography and spectroscopy. Pag hindi 137, wag yung buksan, ibang course yun. Kasi doon ko yung pinupost yung ibang klase ko, recorded na class ko in other school here, based here in the US. But the 137 is the only one that is related with what we have here. Okay. So question? It's 10:30 there or 10:24, 9:24 here in the US. May tanong? May tanong pa? So ready na kayo next week? Kapag yung schedule pala next week, yung graduate research fellowship sa KKP, alam mo na yung anong time, Stephanie?
9 a.m. po, sir.
9 a.m. din? Hala. Paano kaya tayo mag-schedule ng ano natin? Anong oras yung break?
Hindi ko lang po alam, sir. Bale po, for my case po, hindi po ako nag-opt na mag-attend nung fellowship since reporting nga po sa klase po natin.
Okay. Pero kasi wala pa ako yung schedule eh. Alamin ko nga this week kung ano yung day ko eh, yung plenary ko eh. I'm not sure if it's Wednesday there, Tuesday dito, or Tuesday there, Monday night dito. Yun yung ano. And I'm already asking them to send me yung background so I can recorded my lecture well ahead. Kasi minsan nagiging choppy din yung line namin. Like what happened in my Philippine Chemistry Congress talk. I see. Well, Ma'am IB, maybe we can utilize only 1 hour for our reporting, if ever, 9 to 10. And then after that, you're free to do the what we call, yung, kung ano man yung fellowship doon.
I'm gonna wear this tomorrow.
Okay. Hindi yung anak ko eh. Maaga pa kasi. So, any more question? May tanong pa? May tanong pa? Yung tatlo, nag-meeting pa. Si Ma'am Ivy nasa meeting pa rin. So, papublish na lang ni Ma'am Ivy yung sa post-lab mamaya. Okay? So, kapag wala lang tanong, so see you on Monday. So, doon sa hindi pa nag-register, you do the registration. Ako nang bahala doon sa registration fee nyo. Okay? Pa-Christmas ko na lang sa inyo. So, no more question. See you in a
Sir
week.
Elmer,
Yep.
parang dun sa bago sila maka-register, kailangan meron yatang i-upload na proof of payment.
Ganun. O, sige.
Parang dapat mag-pay muna bago sila
Oo,
mag-ano.
sige. Pero kasi pag ngayon ko i-ano, hindi pa rin darating yun eh. So tomorrow morning, i-Western Union ko na. And then
And po sir, bigyan nyo na lang po sila ng ano, ng go ahead na
Oo.
okay
Sabihan
na
ko
or
rin si
something.
Ami.
Opo, pwede po.
Nagpaalam na
Sige.
ako kay Ami.
Okay po. Thank you, sir.
Sige. Okay, salamat.
Thank you po.
Sige.
Thank you, sir.
Thank you po.
Okay.